So we looked at even and odd functions way back at the beginning of the course. An even function by definition has symmetry with the y-axis, all right? But the mathematical definition is f of x is equal to f of negative x. So what that means is the original function, so if we look at x squared plus 1, that should equal f of negative x, i.e. I replace all the x's with negative x. So let's see if we do that. So I replace the x's with negative x. What's negative x squared? There. It's the same, right? Which you kind of already knew because that graph, x squared plus 1, is a parabola moved up 1 unit, right? Looks like that. And you can see it has symmetry with the y-axis. Okay? That's all we're saying. So that's an even function. An odd function means negative f of x is equal to f of negative x. It has symmetry with the origin. So we'll look at a couple of cases here. Y is equal to x cubed. That's sort of the classic one. So we go, okay, is this function odd? That's what we're going to ask ourselves. So we go, okay, negative of the function, this bit, so negative of x cubed, does that equal f of negative x? Negative x all cubed. What happens if you cube a negative? You get a negative. So we end up with negative x cubed is equal to negative x cubed. Therefore, we know it's odd. Which, if you know the graph of x cubed, looks like this. You can see it has symmetry across the origin. Okay. Do you know what I mean when I say symmetry with the origin? This is actually like this bit is reflected that way. Okay. Or math 12, if we did transformations, which nobody likes or remembers, we flipped it that way and then we flipped it that way and you get the graph. Okay. That's symmetry with the origin. All right. Why are these important? Oh, let's actually we'll do the sine functions. The trig stuff's important too. Y is equal to sine of x. Okay. Let's think of the graph of the sine function. What does the graph of the sine function look like? Whoa, I was just going to draw a random graph. Looks like this, right? But we know that it goes like that in both directions. So just looking at that, is sine even or odd? It's odd, right?
Yeah.
Because, whoa, why am I erasing everything?
Because it has symmetry with the origin. Okay.
Essentially being reflected across like that. Okay? Therefore, sine is odd. What is cosine? What does a cosine graph look like?
No. It's still odd. No, it's even.
There's the cosine graph. Is cosine even or odd?
Even.
It's even, right?
Yeah. Sorry for that.
Therefore, it's even. Okay. So why is this important? Well, let's think about this. We'll think about the very first graph, x squared plus 1. Okay. What if I say actually. What if I say to integrate it from -2 to 2 x squared plus 1 dx? What am I asking you there? What is that question asking you? There you go. So what does the graph of x squared plus 1 look like? Looks like this. That's what we're asking, right? Yes? Okay. What do you know about this area from 0 to 2 and this area? They're the same, right? So if you can calculate one of them, you can just multiply your answer by 2, and that's the answer. Now, why do you want to do that? Well, as you know, that means I can rewrite this integral as the integral from 0 to 2 of x squared plus 1 dx, as long as I multiply it by 2. Why is that a good thing? It's easier. When you put 0 into something, it makes it like everything just disappears. We've done enough definite integrals that we've seen when 0 is in there, it makes it nice and clean. Okay? So the big hint of when to be aware of this stuff, and I'm going to write a little formula here at the end, is when the upper and lower bounds are basically equidistant away from 0, or one is positive number and the other one is the negative of the exact same digit. Okay? So from -1 to 1, -2 to 2, -50 to positive 50. That's your hint that, hey, maybe I should look at see if there's symmetry here. Okay? And what if you have an odd function? So we'll look at y is equal to x cubed. So if I say, okay, the area from -2 to 2 of x cubed dx. So now imagine I drew that correctly. What do you know about those two areas? They're the same, but one will be negative, right? Because it's below the x-axis. So what's the value of the integral? It's 0. If it has symmetry with the origin. Because this area is the same as this area, but because this is below the x-axis, it has to be negative. So when you add them together, you should get 0. As long, it's the same thing. If you add the areas together, as long as one of them is above, one's below, you're talking about like that. What's this there? If that's a and negative a, and that's positive a, that's going to be positive, but that's going to be as long as the upper and lower bounds are equidistant from 0. Right? So this is the summary. So an even function, then the integral from -a to a of f of x dx is equal to 2 times the integral from 0 to a of f of x dx. If it's even, all right, then you cut it in half. You go from 0 to that number, and you still got to do some work, but you've got zeros in there, so stuff will usually just disappear. That's if it's even. So the visual is, I can just do a parabola. Here's the visual. Call this -a. Call that a. That area and that area are the same. So it's just 2 times the area from 0 to a. If it's an odd function, then the area from negative a to a of f of x dx is equal to 0. And that's the one we just showed right above, but I'll put another graph here. Let's do the sine graph. And that's y is equal to sine of x. Then you know that area and that area will add up to 0 as long as it's odd. Does that make sense? Okay. So here's the practical example. I guess practical. Let's put practical in quotes. Integral from negative 3 to 3 Now that doesn't look like anything that we've seen so far. Is that even or odd or what? I don't know. Who knows? You'd have to test it. It might be neither. It could be neither. All right. So neither. This is neither.
Neither. So it's not even.
That's nothing, right? That's just neither. No symmetry. Okay, so what do you do with this?
Just test.
Well, you could test it, but it might pop out to be neither, and then you've wasted a whole bunch of time doing that. Okay? But, sorry? Let's plug in 0. Just hope for the best. Okay, but this is a polynomial function, right?
Yeah.
Okay. What do you know about integrals? Do you have to keep them all together?
No.
You can break it apart. So you can do this. I'm forgetting all my dx's, sorry. Okay. Now what have we done? Have we made this a little easier?
Yeah.
Okay. What's this? Is this even or odd?
Odd.
It's odd, right? We just looked at that graph. What about this one? Even or odd? That's odd. That's a linear line. If it's a polynomial function and you break it into its separate bits, like this, just look at the exponent. Okay? As long as it's a polynomial. If you do trigs and logs, that doesn't apply. But if a polynomial, so that's odd, because you can think about, whoops, this graph looks like that, so it's clearly odd. 3x, well, you could pull the 3 out if you wanted, but that is a linear line through the origin, right? Y is equal to 3x. You can see it's odd. So what happens to those two parts of the integral? 0. They're gone. All right. So now we have 4x squared and 6. 4x squared is a what? It's an even function because it's a parabola, right? So we can simplify that integral and go 0 to 3, 2 times that, 4x squared dx, minus integral. Now, x is equal to, or y is equal to 6. Do we know what that graph looks like? It's a horizontal line, right? Where did what? Because you have to double it, right? I changed the bounds. y is equal to 6. This one right here, it looks like this. Is that an even or odd function?
Even.
It's even, right? So that's going to be 0 to 3, 2 times that. And now just solve this. So 4x squared becomes 4x cubed over 3, evaluated from 0 to 3. Just remember to multiply by 2. 6 becomes 6x, evaluated from 0 to 3. Just remember to multiply by 2. And then just plug everything in. And then you could go minus, but you put 0 in and it goes away. That's 4 is 36. Whoops. 6 times 3 is 18 times 2 is 36. So the answer is 36. Does that make sense? People are just randomly writing down. But the point is, if it's a polynomial, okay, just think of it as 4 separate integrals. Make your life easier, right? And if it's an odd exponent, you know it's going to 0. If it's an even exponent, then you can go from 0 to 3. Just remember to multiply your answer by 2. Or, I mean, you can integrate this the long way. You're going to have to plug in -3 and 3, and that's going to be probably fairly big. Okay? Page 302, 69 to 75, odd, please.